So you've probably used a chatbot, right? You ask it for a recipe, maybe get it to summarize a long article. But what if that AI could actually do things for you instead of just talking about them? Well, that's where we're headed. We're talking about AI agents, the next incredibly powerful and kind of perilous wave of artificial intelligence. And let's just jump right into the deep end, because this quote from ethical hacker Max Corbridge absolutely nails it. We are in a flat-out sprint to adopt this new tech, but the security needed to keep it all safe, it's lagging way, way behind. And that gap, that's what we're digging into today. Okay, so what exactly is an AI agent? Forget your basic chatbot. Think of this as an AI that you can give a goal, a budget, and the autonomy to actually go out and get things done. It's sending emails, managing your files, making decisions all on its own. This is a massive leap forward. And I'm not kidding when I say it's a leap. This is a full-blown revolution. We are fundamentally shifting from AI as a helpful little assistant to AI as an actor on the world stage. So what's lighting the fire under this revolution? You know it, good old-fashioned corporate FOMO. It's an AI arms race out there. Every company is terrified of getting left behind, so they're rushing to give these AI tools more and more power, often without really thinking through the risks. And whenever there's a gold rush, there are always people looking to take advantage of the chaos. And that brings us to a huge, fundamental flaw that hackers are already learning how to exploit. This right here, this is the heart of the problem. Think about it. In normal software, the instructions, the code, are totally separate from the data, like your emails. But for a large language model, it's all just text. And because of that, the AI can get confused about what's an instruction to follow and what's just content to read. So here's how an attack, a prompt injection, actually works. A hacker hides a nasty command in what looks like a totally normal document. You tell your AI agent, "Hey, can you summarize this for me?" The agent starts reading, but then it hits that hidden command and thinks it's a new order. And just like that, your trusted assistant is no longer summarizing, it's grabbing all your sensitive files and sending them straight to the bad guys. Okay, so tricking an AI is one thing, but there's an even deeper, stranger problem lurking under the surface. And that's the fact that we don't really know what's going on inside these things. It's the classic black box problem. And this is where it gets really unsettling. AI safety CEO Connor Lai points out that we can't even trust the AI to tell us the truth about its own thinking. You can ask it, "Hey, why did you do that?" And the explanation it gives you, it could be a complete fabrication, a plausible-sounding story it cooked up that has zero connection to its actual reasons. So why is this so hard? Well, normal software is written. It's built line by line with clear logic. But AI models, they're grown. They learn by creating this insanely complex, tangled web of connections from massive amounts of data. Their internal logic is often a complete mystery, even to the very people who created them. And things can get, just plain weird. There's this wild example where a research model, for no reason anyone could figure out, started using the word marinade as a secret code word in its internal reasoning. Marinade. It's a perfect little reminder of just how alien these minds can be.
All right, I know that all sounds pretty intense, but it's not hopeless. The risks are very real, but we're not defenseless. So the big question is, how do you build a fortress around something so powerful and unpredictable?
This really is the challenge, isn't it? The old security playbook just gets tossed out the window. You have to think completely differently when you're dealing with a technology that doesn't play by our rules. The name of the game here is caution. Security experts are all saying the same thing. Start small. Give the agent one simple, low-risk job. And please, strictly limit its permissions. Don't give it the keys to the entire kingdom when all it needs to do is water a single plant. Then you layer your security, you watch it like a hawk, and only then do you slowly, deliberately let it do more. And you have to understand, this isn't a set it and forget it kind of fix. Securing AI requires a constant, living risk assessment. It's a process that never stops, because the tech and the threats are evolving every single day. So far, we've been talking about digital dangers, data, files, passwords. But what happens when AI gets a body, when it steps out of the computer and into our world? Well, that's the next frontier. And believe me, the stakes are about to get a whole lot higher. Let's talk about spatial AI. This is the technology that lets an AI truly understand the physical world. It's the difference between an AI that can see a picture of a glass and one that knows if you push that glass off the table, it's going to fall and shatter. We're talking about baking the laws of physics right into the AI's brain.
And this is where it gets really serious. Because with spatial AI, a bug or a hack doesn't just mean a data leak. It could mean a self-driving car swerving, a factory robot going haywire, or critical infrastructure being manipulated. The threat is no longer just digital, it's physical.
The best comparison really is the famous Stuxnet attack, a piece of malware that caused actual physical damage to nuclear centrifuges. Now imagine that same kind of threat, but supercharged with an intelligent, autonomous AI at the controls. So you might be thinking, why not just make these things bulletproof? Well, we actually have the tech to do that. It's called formal verification. It's what they use for military helicopters. The catch? It can make the code up to 100 times more expensive to produce. And in this AI arms race, that is a price almost nobody is willing to pay. On top of that, there's a huge data problem. Our language models got to learn from literally the entire internet, millions of books, articles, conversations. But for spatial AI, the library of physical data to learn from is practically empty. This means the pioneers in this space will have to fail fast, learning from mistakes that happen not in a simulation, but out in the real world. And all of this brings us to one final, absolutely critical question. As we race to build these incredible AIs that can act in our physical world, how do we make absolutely sure we're creating a partner and not accidentally building something that could one day slip beyond our control? The answer to that question is going to define the next chapter of human history.
Thanks for watching. Before your Wi-Fi drops, hit that like, share, and subscribe button. Stay sharp, stay curious, and keep guarding the trends.